Okay, everybody, welcome to day 9. Welcome to day 9. You may refresh your screen. You can refresh your screen. Welcome to day 9. Welcome to day 9. Welcome to day 9. Welcome to day 9. Welcome to day number 9. If you have been with us so far, type 100%. 100% if you have been with us from day 1. Type 100%. If you have been with us from day 1. Day 1 we discussed the outline. We take a dive loop of build tools that we're going to make use of, and from there we went to development, where we have to talk about variables, which is temporary data storage, and we describe data types. We deep dive into data types like strings, methods of strings. We look at integers, number, various primitives, and then objects. From there we went to array, and then array we moved to collections. I think on day 8 we went back to reviewing everything from the beginning, and then we touched down on our assignments. On day 8, wasn't just a student assignment that was given to you. We had more assignments that were given, which I think we did not cover. So we need to take a look at that today for our assignment. We take a look at that today, the rest of the assignment. But before we do that, I talk about object-oriented programming. And what did I say about object-oriented programming? What did I say about objects? How do we identify 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 objects? If you are there, let me know. How do we identify objects? How do we identify objects? What did we say about objects? What did we say about objects, and how do we identify objects? You can just type on the screen what you understand by objects. So we talk about object as noun, Then I gave my own definition of objects. Who can remind us? I gave a definition of an object within the problem statement. I know. Not that I gave when you have a problem or a project, I used that as a way of defining objects. Can you recall what I said about that? Well, I said that an object, just like you have now, an object is anything that can be referenced or acted upon within a problem statement or within a context. So anything that can be acted upon or referenced. And with that, we try to look at our various applications that we are to write. And in those applications, we look at car hailing system. And by definition, we say it's a system whereby passengers have to wait to be driven by a driver over a course of distance and gets charged for the service. So if we take a look at this problem statement, we have passengers who could also be identified as riders. So we have riders who are waiting to be driven by a driver. And then what is the mode of conveyor? You have a car, you have a driver, and then you have a rider. And then they took a journey over a distance. And we say that this journey, we can call it a trip. And then they get charged for the service. So when you get charged for a service, what does it mean? It means you purchase a service. So there is a purchase. And that purchase is called transaction. So by that, we're able to identify a driver, we're able to identify rider, we're able to identify a car, which are more visible within a problem statement. The ones that were not mentioned that are not that visible, we're able to underline them, which are like trip, booking, and the transaction. We also move over to the second one that looks like it, which is an ordering app for cake. We said that it's a system that allows customers to place order for a cake or pastry and make a payment and have it delivered. So here we are talking about a system that allows customers. So we are referencing customer now to place order. So what do you place? Order. So there is a reference to what is called an order. Then order for something. Here it is cake, but cake are different types. So in that case, we use another broad name to categorize them, which we call item. And then from the item, we move over to from the item, we also move over to payment, which needs to be made. That is how we identify objects. Now, just like you have an object as an entity that has attributes. It has properties which has the attributes, and then it should have a kind of function. Take an example. We have human being. What is the definition of human being or living thing? Because human being belongs to the class of living things. In our basic definition of living things, what can we say about living things? By definition, we know that living things can bear name, that is a property. They can bear name, that's property. They can bear kind, that is a kind of the living thing. You have mammals, because they have mammary glands. And then you have vertebrate and invertebrate animal. You have like mollusk and all that. Because they are kind of living things. They are kinds of living things. And so because they can be classified, but generally for living things, we know that they possess these attributes. They can be named. You understand? They can be named. They can be found in a particular place. They belong to a kind of category which we can say, okay, we have kind as an attribute. But the other attributes of living things, yes, they can move, they can make sound, they can breathe, they can give birth. Now, get it right now. They can move, they can eat, they can give birth. These are actions. These are actions that are being performed by the living things. So which means that a living thing has some attributes which could be name, which could be kind, and then also can execute some actions. Those actions could be move, could be eat, could be make sound, could be respire, could be reciprocate, could be reproduce. So they are action words, right? So those action words are if you translate it to Java, an object becomes a class. The attributes of the object becomes the property or variables of that class, and then the actions that the object can perform are the methods intrinsic to that class. Do we get it now? If you get my definition up for this month, say fine. Write fine on the screen. Write fine in the chat box. Let me know if you get it up to that point. Say fine. Say fine. Write fine. If you get my definition so far. If you get my definition so far, write fine. Right, fine, great. So, in summary, an object is anything that can be referenced or acted upon within a context or a problem statement. And then an object could have attributes and actions that they can execute. They may not necessarily have actions to be executed, but at least they will have attributes to be executed. So those are objects. Like the objects we have identified now. So we started with customer. Like a customer will have a name. We can reference a customer by saying that we are assigning an ID to that customer, which could be a personal number or whatever to identify that customer. It could be also the phone number. Any unique thing that can be used to identify the object. So email. Now we're also saying that these properties could be modifiable. These attributes could be modifiable, and the only way you can modify them, or a way to modify them, is to do what? Is to have another functions called setters and getters. When you define a variable, you use the getters to retrieve the value or the property that is assigned. You use setter to update, to modify the field in that class. For example, you will not want to change the ID of a customer once that customer is created. So if you cannot change the ID, you can make the ID finer. Like I said, when you make it finer, it means that it cannot be modified once a value is assigned to it. That's what finer means. It's often used for constant. So you use finer, to modify that. For the rest, if they can be modified, then you don't use finer. So as the assignment I gave was, I said in your repository now, you are going to create a new folder. You are going to create a new folder under the assignment. You are going to create a new folder under the assignment, and in that folder, okay, let's not do that. Okay, in the root of our project, we will create a folder representing each of our projects. For example, I will have orders. That's the folder. That's a folder. Then for the one that is in the car hailing app, let's see, Uber clone. So you are going to create those two folders. Now after you have created, I'm not saying that each of you will create those two folders. You only create a folder for your own project. If your project is others, just create other as in the root of your in the root of your in the root of your class, not inside assignment folder, but it should be outside the assignment folder. So that in the root I can see the others, I can see overcload. So you create this folder for yourself. Then you look at based on what we have talked about, you will look at all the objects that we have identified for your own project. Look at all the objects that we have identified for your own project. So for those objects, create a class for them. So if you have driver now, so that means inside the Uber clone folder, you have a driver.java, rider.java, trip.java, booking.java, transaction.java. For others, you have a customer.java, order.java, item.java, payment.java. Then you need to also identify what are the properties of each object. In this context, we have say we have a car now. A car will have a plate number. You understand? If you are dealing with driver, a driver has a name. A driver has maybe a car that is assigned to the driver with a plate number. The driver could have a number of trips completed, rides completed, or total rides, rating, and things like that. For rider we have a name. Rather, we have maybe total trips. Maybe you want to put gender of the rider. And then we have trip. For the trip, you have pickup and destination. Pickup, destination, total hours, then waiting period. So you have waiting period, you have total hours spent on the trip, you have the pickup point, and then you have the destination. For the booking, booking will contain information of you have a rider. A booking will have a rider, and it will have a driver, and a trip attached to it. And then for transaction, a transaction will make use of a booking. We have booking, and then we have a total amount based on the total distance. Then a car we have a color model, that is for car. A car should have a color, it should have model, and have a plate number. For customer, we already identified the customer. For order we contain what is being ordered for. Will contain list of items. Another will contain list of items, and then the total cost, and then will contain customer also who is placing the order. An item will have a name and description, and then the amount, maybe cost of maybe a price. An item should have ID, name, price, if there is any discount, whatever, and things like that. Then we have a payment. A payment contains what? Total amount to be paid, maybe the mode of payment, transfer, card, and things like that. So your assignment for day 10 is that these classes must be ready. Then you create getter and setter for them. Here we have customer, and then we did get ID, which returns the ID. We have set ID, which update the ID, which updates the ID. If you are missing anything, you can check back from the master branch. You will see some of this information in the README there. So create all those objects, write the setter and getter for each of the properties that you have identified. If you have gotten the assignment so far, just write clear. Okay, great. So we have that. Then I'll go back to objects. We still have some more time. Let's see if we can spend that together. So for the object, I've only talked about object as an object. An object can have properties, which is the getter and setter for the functions and things like that. But there are also what we call helper functions. Helper functions are the functions you write that to perform some other micro task, or maybe provide a clarity to the block of code that you are writing, so that you don't have a kind of complex code. So in object-oriented design, we'll be looking at some design concepts. First, we'll look at what is called polymorphism. Polymorphism. Poly means many. So polymorphism means many methods or functions, which means that an object can have or a class of an object can have many methods, can have many functions to be performed. An object can have many methods or many functions to be performed. That's what polymorphism does. Just like you saw the getter and setter, you realize that it's not just one method that we have for that class of or object. We have many other functions that it can perform. So polymorphism. So we can write as many functions, for that object. Another one is what we call inheritance. Inheritance is like how would I put it now? If you have a girl, and then it's an hierarchy of attributes that is being shared. Let me use a base class now. Let's call a base class car. Say a car should have tire, steering as an attribute. For it to be called a car, it must have minimum of 4 tires. And then it must have a steering. and then the, let's say, a tire, tray, and the steerings, then let's say minimum of 2 doors. Minimum of 2 doors. Minimum of 2 doors. Let's say that is our, our car or vehicle. Okay, let's just say vehicle, a vehicle. Now from vehicle, you can have a vehicle can be classified into different categories. It could be lorry, it could be car. If it is lorry, maybe it will have about 6 tires minimum. 6 tires minimum, 4 at the back, 2 at the front, to be able to carry load. You understand? And therefore the makeup, it must have a container, maybe behind, and then no passenger seat at the back. But for car, we can say that it has 4 tires, and then there is maximum height that you can have for the car. For you to call it a car, it must have 4 tires. It still have a steering. So if you look at it, you realize that vehicle and lorry and car are sharing some properties, which is the number of tires, at least minimum number of tires, and then they have steering. So what is different is the body design. What's the difference? It's the body design. And then from car, you can even create another car. From car, you can say, okay, this one is called Mercedes. Mercedes will have everything that every other car has, but the design may be now different. Design, the rear lamp, the logo, and the color, and the model will help you to identify a car as a Mercedes car. So you will see that there is an hierarchy of descendants of properties that they shared. So that is why it is called inheritance. So you can have vehicle. From vehicle say has these properties. 4 tires, say 4, and then it has passenger seat. Passengers, say minimum of 2 rather, minimum of 2, and then it has steering, which is 1 or must always be true. Now this is for a vehicle. Now if you break this down, and you create car, you will not need to repeat all these other properties. Here, what will change for a car, we will now say, okay, maybe passengers. If it is 2, we leave it at 2. Maybe doors, and we say, okay, it has 2 doors or 4 doors, and then tires remain 4 tires. Since it remains 4 tires, that's not an additional thing. So what else? Steering, it always have 1 steering, so there is no need to add another attribute for steering. So you discover that everything that this vehicle has is what the car has. However, let's descend this one and create another car, and now say that let's say saloon, let's call it SUV. Let's call a car SUV. SUV is descendant of other cars. We can say that SUV, for SUV, we now have maybe the type of boot or trunk for the SUV. We have tire type, maybe high tires for SUV. It will still be 4, right? Then how many doors does SUV have? SUV we have 4 doors. So here we say doors 4. So every other thing, steering, it still has it. So just like another example, let's say human being. For human being, let's say it has name, and then it has some method. Here for a vehicle, before we can call it a vehicle, it must have these attributes, and it must be able to speed. It must be able to do what again? For a car should be able to speed. It should be able to reverse. A car should be able to reverse. What other thing can a car do? Okay, let's say speed, reverse, or decelerate. So accelerate, decelerate, everything is inside the speed. So a vehicle has speed and reverse. So which means that when you are creating car, you only inherit every other thing. You inherit the speed, you inherit the reverse, you inherit the steering, and then you update the passenger to be equals to 2 or to 4, or doors to 2 or doors to 4. When you are treating SUV is a descendant of car, and you can see it has a big trunk, that is trunk type, big. So, and then tires, maybe this time around tires is, you have 4 tires. If it's 4 tires, then there is no need of adding that property. Then doors, the doors must be 4. For every vehicle, they have doors too, right? So doors, maybe doors minimum of 2, but for SUV, the door is 4. So the door is 4. You can see it. So the same way we can have a human being, and the human being have gender, right? Human being, it has name. Let's say 2 eyes, 2. What else for human being? Can walk, can talk, can respirate. So these are for human being. Let's say this is for human being. Human being can respirate. We are still dealing with inheritance. Inheritance means that you can take a property of the parent class. So in this case, the parent to a car is the vehicle, and the parent to a SUV is car. Now here we have human being. From human being, you can have man, you can have woman. So which means from here we can add another attribute to human being called gender. Okay, we already have gender. So here, so when we are creating man, what do? When we are creating man, we simply say that for man, we say gender. Let's say the gender is called man. For woman, the gender will be this. Then there's other private stuff. There are things that a man has that is not shown to everybody. In fact, this is a way to explain what we call access modifier. I think I talk about access modifier in our 2 years, inheritance, parent-child relations. So you can see the hierarchy. So you have anything that can be exposed for everybody to see is public, and that is why they call some things private parts. So it's private because it should not be seen by the public, which means that it's only that person that can access it. So the same thing is a class. When you have a class that has a property that is marked private, it's only that class that can access it. So we have for man, and then we can say gender is man. You understand? And then maybe we can say masculine, say true. You understand? For woman, we can say masculine false, and then feminine true. You understand? So those are it. So in writing a program, how do we ensure that? Okay, another way that we can talk about inheritance is a way of not duplicating all properties, is to avoid writing the same thing all over again. For example, say we have vehicle and it has tire, passenger, steering, speed, function, speed, method, reverse method, and then another attribute, dots. And then you want to write another class called car Java, which already has the same thing that a vehicle has. It means that you will have to define all this in the car class. When you get to SUV, you will define everything that is in vehicle and everything that is in car. You will define them in the SUV along with the trunk and other information. So that makes it duplicating efforts. That means duplicating effort and properties and things like that. That is why we use inheritance. Inheritance for us to be able to avoid duplicating what we have written before. So, for example, we can start with a class called vehicle, public class, vehicle, right? And we say that this vehicle has integer tires, say integer passengers, what else do we have here? We have, let's say, Boolean steering, right? Then doors, integer doors. Then we have some methods called say public void reverse. Now if you look at this definition, when you are reversing, what happens when you are reversing? Public void accelerate. Let's look at this, and then say public void decelerate. I'm sure all of us have driven car before. So let's quickly look at this vehicle. When you are accelerating a car, what do you mean by that? when you are accelerating, what do? You are simply increasing speed. So there is something that we have not defined in vehicle. We need speed. Say integer speed. If you create a constructor, the speed should be 0. Now, so when you accelerate, you press the gear zoom, maybe you gain 5 speed. Let's say integer accelerate. Is it torque? What is torque? I think you should find out about that. So when you accelerate, what you just do is that this dot speed plus I will give us shorthand for that, but let's just take it this way. This dot speed equals to this dot speed plus torque. Let's say this our torque is the speed gain. Now, if you decelerate, what does that mean? If you decelerate, it means that we are reducing the speed. So this dot speed will just be minus. No. Then what about a reverse? What about a reverse? How do you reverse? Then you move backward, isn't it? That means we have what we call direction into the direction, integer direction. So you reduce the direction when you are reversing. So that means that we can say that let's say integer torque again, which is the speed. Let's say this time around this dot speed, this dot direction rather. This dot direction minus equals to torque. This is the same thing as what I wrote earlier on. So this one, so you have this public void reverse. This is a direction minus equals to torque. Is the same thing as saying this does direction equals to this does direction minus torque. So minus equals to, for example, if I want to say I can do a shorthand of this one and say this dot speed plus equals to torque. So it's the same thing as this same whole line of statements. So now that we have this, what do? Let's now create car. So we can say class car, because public class car, because car already has a property that a vehicle has, so we'll say extends a vehicle. So we will not write everything about vehicle and duplicate it in car class again. So what we'll simply do is that what properties do we want to add from the car? We only need to add Here we are saying that a car is what? Maybe we are retaining doors. We are adding doors. Say, okay, here for car, public car, and then for car, maybe for car, so for car, we can say this door equals to 2. And then every other method, getter and setter, can be inherited. So we don't need to rewrite them and things like that. So that is it. If you want to do SUV, we do that the same thing. So that is it, and that is where we are going to end the class today. So you are going to create these classes using inheritance. For vehicle, you create a vehicle class which has all this method. You create a car class that inherits from vehicle. Create a car class that inherits from vehicle, and that is it. So, and then have the getter and setter for all the three class, that is car, SUV. Let's have lorry. Let's have lorry for a type of vehicle. Now let's have that. So please create 3 classes in the same folder, not in the assignment folder now, in the same folder where you have the students.java. In the same folder where you have students.java, create a file called vehicle, and then okay, let's do like this. You create a folder called objects. So I think create a folder called objects. So inside the object folder, you will see have let's do like this. The vehicle, whether it's vehicle or car and things like that, they should end with your repository name. So if your repository name is Saka, it will be vehicle then followed by capital S, Saka. If yours is fuel, it will be vehicle fuel with capital P. So I will be able to use that to differentiate each of your classes. If the assignment is clear to you, write clear. If not, ask question now as we close. I'm waiting. If you are clear with the assignment, just write clear. Then we can close. So we'll close in 2 minutes. I'll still wait. I'll still wait. Clear. Great. So we'll see for our day 10. We will ensure that we cover interface. We'll look at interface and implementation of interface. After that, we'll go into writing some, go into server-side coding and see what we can do, because by day 11, we'll switch to front end. We'll do front end for like 4 classes and come back to the back end. So thank you so much for making yourself available for day 8, day 9 rather, and I'll look forward to seeing your assignments done and implemented. Okay, so let's do it that way. I will push the update now so that everybody can be in sync. Okay, so I've pushed the update to what we discussed today online, so you can check the master branch if there is anything unclear for you to see. Thank you so much again. We'll see in day 10. Bye.